Good morning, students. Your teacher here, Mr. Sarasinski, with another episode of Algebra 1, and we are deep into the unit of quadratics. And this lesson is 8.14, Projectile Motion. Okay, and this is one of the biggest reasons why we even study quadratics, this and modeling, because we need to know things like this. You can probably imagine when missiles began to be developed, the importance of quadratic equations and the importance of knowing the x-intercepts, because that's where missiles land, right? So, as we study this, just kind of think about some of the reasons why this could be important, which I just mentioned one, but I'm sure there are thousands of others. So as we work through some of these examples, one of the biggest, the biggest things we're going to be looking for are the vertex, okay? And this will be asked in different ways. What's the maximum height? How much time until it reaches its maximum height? So in some scenarios, you're going to be asked for the x of the vertex. Some scenarios, you're going to be asked for the y. And then the x-intercept. So it's going to ask us for the roots. It's going to say, at what time does the ball hit the ground, or questions like that. So everything is going to be associated with the vertex and the roots, both of which we know how to find in a couple different ways. So let's get started. A soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h equals negative 16t squared plus 90t gives the height h of the ball after t seconds. Find the maximum height of the ball. Well, the maximum height of the ball is the y value of the vertex. So first, let's find the axis of symmetry. It's negative 90 divided by 2 times negative 16, right? Because A is negative 16, B is 90, C is 0. And negative 90 divided by negative 32 equals 2.8125. And then if I substitute that back into my calculator, back into the equation. So negative 16 times 2.8125 squared plus 90 times 2.8125. I get, let's see here, 2.8125 squared times negative 16 plus 90 times and I got 126.56 feet. All right, so the soccer ball was 126.56 feet at its vertex. How many seconds will it take for the ball to reach the ground? Okay, so now we're looking for the x-intercept. And on this one, I am going to suggest that you take the equation and you put it into your calculator, to your y equals, and you look at a graph. Negative 16x squared plus 90x second graph. And if I trace, it looks like it hits the ground around 5.625 seconds. Okay, so using your calculator works great, and you can put that equation into your y equals. You can go to the graph and you can scroll. You can hit the button trace right next to graph on your calculator, and it will show you pretty close to where the line crosses the x-axis, but not exactly. So in this case, I just used the quadratic formula and set it up. Since c was 0, this part canceled out. Okay, so I got negative 90 plus or minus 8100 divided by negative 32. And the square root of 8100 is 90. So negative 90 minus 90, negative 90 plus 90 cancels out, which is the origin. Okay, that's where the ball was kicked from. Negative 90 minus 90 is negative 180 divided by negative 32 actually gave me 5.625 seconds. Okay. So there's more than one way to get the answer here. Your calculator is a great tool, but also knowing the quadratic formula, you can simplify any of these. Okay, so make sure you have this formula memorized. It can be a big tool for you. So number 1A, the answer is 126.56 feet, and 1B is 5.625 seconds. Okay, next example. An apple is launched directly upward at 64 feet per second from an 80-foot tall platform. The equation for this apple's height, h, at time t seconds after launch is h equals negative 16t squared plus 64t plus 80. So A equals negative 16, B equals 64, C equals 80. Find the maximum height of the apple. So we're looking for the y value of the vertex. So first we have to find the axis of symmetry. Remember that formula is negative b divided by 2a. And that gives us the x value of the vertex. Okay. So x equals negative 64 divided by 2 times negative 16. And that is negative 64 divided by negative 32, which is positive 2. Okay, so the x value, that means it's 2 seconds after it's launched, it reaches its maximum height. Now we can substitute that back into the equation. Okay, so h equals negative 16 times 2 squared plus 64 times 2 plus 80 equals the height at its vertex, which is the maximum height. And I can just put this into my calculator just as I wrote it here. Okay, so negative 16, 2, in parentheses, squared, plus 64, parentheses, 2, plus 80, enter. And I got 144 feet. Okay. B, how many seconds will it take for the apple to reach the ground? Once again, they're asking for the x-intercept. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so we simplify this down. Always start with the discriminant. Okay, this value underneath the radical. Always start with that. All right, so 64 squared, and you can put it into your calculator just as it's written there, minus 4 times negative 16 in parentheses, 80. I left that piece off. And you get 9216. So we have negative 64 plus or minus the square root of 9216 divided by negative 32. And the square root of 9216 is 96. So this is going to be 2 answers. X equals negative 64 plus 96 divided by negative 32. And x equals negative 64 minus 96 divided by negative 32. Okay, So the first one, negative 64 plus 96 divided by, let's just divide it by negative 32. It's going to be negative 1. Okay, so that's not going to be my answer, right? It's definitely not going to take negative 1 seconds for this apple to reach the ground. So negative 64 minus 96 is negative 160, divided by negative 32 is 5. So it took 5 seconds for the apple to reach the ground. All right, number 3. In science class, the students were asked to create a container to hold an egg. They would then drop this container from a window that is 25 feet above the ground. If the equation of the container's pathway can be modeled by the equation h equals negative 16t squared plus 25, how long will it take the container to reach the ground? Find the maximum height of the container. Again, this is the y value of the vertex. So we need to use the axis of symmetry formula. In this equation, a equals negative 16, b equals 0, c equals 25. There's no b. If there's no b, b is 0. So that's negative 0 divided by 2 times negative 16. All right, so if b is 0, then the x value is going to be 0. That means, hello, this thing was at its maximum height because they're dropping it from a window. Now let's see what happens when I plug this into the equation. H equals negative 16 times 0 squared plus 25. Well, 0 squared is 0 times negative 16 is 0. So this is just going to give me 25 feet. So this thing was at its maximum height when it was dropped from the window. Never went any higher. They didn't throw it up. They just dropped it. Okay. B, how many seconds will it take for the container to reach the ground? All right. So set up your quadratic formula. Negative 0 plus or minus the square root of 0 squared minus 4 times a times c all over 2 times a. Always simplify the discriminant first. And you can do that in your calculator. So 0 squared is 0. Negative 4 times negative 16 times 25 is 1,600. So this is going to be negative 0 plus or minus the square root of 1,600 divided by negative 32. And the square root of 1,600, that's 40. So this should be x equals negative 0 plus 40 divided by negative 32, and negative 0 minus 40 divided by negative 32. Okay, if we do the first one, 40 divided by negative 32, that's negative 1.25. And that is not going to be our answer because it's negative. We don't have negative time. Okay. Negative 40 divided by negative 32 is positive 1.25 seconds. So it took this container 1.25 seconds to reach the ground. All right. H. Number 4. A penny is dropped off the Empire State Building, which is 1,250 feet tall. And there's that old, question. It's an old question if you dropped a penny off the top of the Empire State Building, would it kill someone if it hit them? All right, so, and here's the equation. It can be modeled by h equals negative 16t squared plus 1,250. How long would it take the penny to strike a 6-foot tall person? Okay, so let's think here. If the Empire State Building is 1,250 feet tall, then we're actually looking to see when it reaches 1,250 minus 6, right? Because if it's going to hit him on the head, it doesn't have to go all the way to the ground. So that's going to be 1,244 feet. All right, so we need, so we're gonna set the equation up like this. 6 equals negative 16t squared plus 1250. Subtract 6 from both sides, and we get negative 16t squared plus 1244. That's what we need the height to be, okay? Because it doesn't have to go all the way to the ground anymore. Now, there's no b term, so that's a clue that we can solve this by taking the square root, okay? So, subtract 1244 from each side. I'm going to have to bring this over here. So we get negative 16 t squared equals negative 1244. Divide by negative 16. T squared equals 1244 divided by negative 16. 77.75. And then take the square root. Square root of 77.75 is 8.82. So plus or minus 8.82. And it's not going to be the negative version here. It's going to be the positive. Sorry about the bells. 8.82 seconds to hit a person on the head who's 6 feet tall. And probably kill them. Sad story. All right, so number 5. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height, h, at time t seconds after launch is h equals negative 16t squared plus 80t. So A equals negative 16, B equals 80, C equals 0. How long will it take the fireworks to reach the ground? So it's asking for the x-intercept, right? Okay. So first thing we need to do is, well, solve it. How do you think the easiest way to solve this? There's no C term. It looks like there's a GCF. So let's try this. H, and we're going to substitute H for 0. Negative 16t squared plus 80t. And both terms looks like have a GCF of 8. Actually, I'm going to take out negative 8. And then both terms have a variable. They both have a t. And if I take that out, what's left? So let's see. So this would be 2t plus, I'm sorry, that's going to be minus 10. Okay. So negative 8t equals 0 divided by negative 8. And that one is t equals 0. Obviously, because whenever something's launched, it's launched from 0. It's launched from the origin. And then 2t minus 10 equals 0. Add 10 to both sides. 2t equals 10 divided by 2, and t equals 5. So it took 5 seconds. Ended up not even needing this. Just did GCF. How did I know to do GCF? There was no C term. So that was my clue. Plus 16 and 80 have a common factor. It was really obvious to me that it was 8. All right, let's keep going. Number 6. The Apollo's Chariot, a roller coaster at Busch Gardens, moves at 110 feet per second. The equation of the ride can be represented by the equation h equals negative 16t squared plus 101t plus 10. What is the maximum height reached by this ride? So this is, if it's maximum height, we're looking for the y value of the vertex. Okay. All right, so we need to find the x value first. So A equals negative 16, B equals 101, C equals 10. And we just set up the axis of symmetry formula. Negative 101 divided by 2 times A. That's negative 101 divided by negative 32. Get my calculator out. That is 3.15625. And anytime I'm doing problems like this, I kind of like to use the full decimal as long as it's not too long. This one's pretty long, but I'm going to stick with it. So H equals negative 16. Just plug this back into the equation. 3.15625 squared plus 101 times 3.15625 plus 10. All right, and you can do the math in your calculator. Just type it in as I've written it here, 3.15625 squared plus 101 times 3.15625 plus 10. And when I did that in my calculator, I got 169.39 feet. Okay, number 7. Eva is jumping on a trampoline. Her height h at time t can be modeled by the equation negative 16t squared plus 20t plus 6. Would Eva reach a height of 14 feet? Okay, so they're asking us, will she ever reach a height of 14 feet? Well, we can tell a couple of ways. We can tell by calculating the vertex and seeing if, the maximum height of the vertex is 14 feet. If it is, yes. If it isn't, no. That's, pretty easy way to solve this. So we're going to find the y value of the vertex again. A equals negative 16, B equals 20. C equals 6. We're not going to need C here. X equals negative 20 divided by negative 16. Negative 20 divided by 2 times negative 16. And that's going to be negative 20 divided by negative 32, which is 0.625. So it only takes 0.625 seconds for her to reach her maximum height. And then that height is h equals negative 16 times 0.625 squared plus 20 times 0.625 plus 6. Okay. And I'm putting this into my calculator just as I've written it there with parentheses and all. And I get 12.25 feet. So if the maximum height at the vertex is only 12.25 feet, then she never reaches a height of 14 feet. So the answer is no. And last but not least, an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second. Letting go of the baseball 2 meters above the ground, the equation of the baseball pathway can be modeled by h equals negative 0.8t squared plus 10t plus 2. The same experiment is done on Earth, in which the pathway is modeled by the equation h equals negative 4.9t squared plus 10t plus 2. How much longer would the ball stay in the air on the moon compared to the Earth? So they're asking for the x-intercepts, right? So each one of these parabolas is going to look like this, okay? So they're looking for where, after it's thrown, how long does it take before it hits the ground, okay? So we're going to have to calculate the roots for each of these. Now, looking at them, they both have a, b, and c. So it looks like quadratic formula for both. Okay, so let's do the first one. A equals negative 0.8, B equals 10, C equals 2. Then I'm going to do the other one in a different color. A equals negative 4.9, B equals 10, C equals 2. So the main difference is the A value. And that should make sense because A affects the how like stretched the quadratic graph is. If it's greater than 1, you know it's stretched. If it's less than 1, and between 0 and 1, it's compressed. And so each one of these, I know that this graph is going to be much more stretched than this graph, okay? Just based on the A value. All right. So let's do the one on the moon first. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And we'll simplify the discriminant first. So 10 squared is 100. And then I'm just gonna multiply. I'm gonna do this out in the calculator. 10 squared minus 4 times negative 0.8 times 2. And I got 106.4 all over 2 times negative 0.8. 2 times negative 0.8. That's negative 1.6. So this is 10. Let's see, the square root of 106.4 is 10.315. So x equals negative 10 plus 10.315 divided by negative 1.6. And x equals negative 10 minus 10.315 divided by negative 1.6. And in the first one, if you do that, you get 0.315 divided by negative 1.6, which is a negative. Our answer is not going to take a negative amount of time, so it's not going to be this one. Now, negative 10 minus 10.315 equals negative 20.315 divided by negative 1.6 is 12.697 seconds. So on the moon, it takes 12.697 seconds for the ball to hit the ground. And now let me clear out some space to work my other example. Okay, so x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, so simplify the discriminant first. X equals negative 10 plus or minus 2 times negative 4.9. That's 8. That's 9.8. That's going to be negative 9.8. Now let's simplify the discriminant. 10 squared minus 4 times a, which is negative 4.9, times c, which is 2. And I'm putting it in my calculator just like I wrote it there. And I get 139.2. Okay. And the square root of 139.2 equals 11.798. So that's x equals negative 10 plus 11.798 divided by negative 9.8. And x equals negative 10 minus 11.798 divided by negative 9.8. And in this first example, the answer is going to be negative. It's not going to be that one, guys. Okay? So negative 10 minus 11.798 divided by negative 9.8 is 2.224. So it's only 2.224 seconds here on Earth. That's a big difference, right? And if we subtract those, 12.697 minus 2.224, we get 10.473. So the difference in how long it would take the ball to hit the ground on the moon compared to on Earth is a pretty long time. Imagine just standing there and watching the ball for 10 seconds. I think in perspective, it's hard to imagine maybe, but in perspective, that's like a lifetime throwing the ball. Like playing catch would be a lot slower. But anyway, guys, I hope you enjoyed this lesson where we got to apply some of the concepts we've been learning and some of the methods of solving that we've been learning to these real life problems. I am your teacher. This is the way.